METACO Talks. I'm Seamus Donahue, the VP of Strategic Alliances at METACO. If this is the first time you're joining METACO Talks, this is a bi-weekly podcast where we invite thought leaders from the digital asset space to discuss their operations, current events, and the opportunities in an exponential future. Today's topic is giving institutions full control over the data. To discuss this, we're joined by Peter DeMeo, the head of digital asset infrastructure at IBM Systems. He globally leads IBM Systems Crypto Asset Solutions for institutional custody, exchange wallets, and tokenization, which require advanced secure private key management. He's responsible for market development, technology roadmaps, and building sales and service infrastructure. Welcome, Peter.
Thank you very much. I feel like a startup inside the big blue.
Well, that's a good place to start. The Big Blue, I mean, we've been around since, I think Big Blue's been around since 1911, so 110
That's
years.
right.
You're not, it is not necessarily a startup in terms of age, but clearly what you do is probably, in that context, is a very new, modern thing. So it'd be great to hear your, how you got into digital assets and also this journey with IBM.
Sure, thank you. First thing I want to say is that this is not a talk about Hyperledger Fabric. So
Thanks.
At IBM, most people associate IBM and blockchain as with our Hyperledger Fabric and permission blockchains and things of that nature. And that all started back in 2016. And I personally got into the space and in the permission blockchain space also in about 2017. And then towards the end of 2017 with all the ICOs and everything else, and I'm like, wow, digital assets seems like it's a lot more exciting than permission blockchains and supply chain and tracking flowers and, whatever, this ICO stuff is kind of fun. I mean, I didn't do any of it because I wasn't really understanding a whole lot at the time, but it was really fascinating. So in the beginning of 2018, really started to pay attention to all of those exchange hacks. And I see, it's funny, just leading up to this talk, I was reminded again that, the thing that got me into this is the thing that keeps me into this. There was an article today, it was recently, like Tuesday or something like that, with, if you remember the New Zealand crypto exchange called Cryptopia, several, I think like 1.5 million people that were using that exchange, it was hacked, everyone lost their money, the same story you hear all the time. But it's really interesting to hear was that prior to the collapse, if you like, one of the staffers persuaded the Cryptopia management to discuss security related matters, and essentially enable that person to ultimately get access to the private key of wallets. And as we know, there's an omnibus model, at exchanges. And so if you have a key high enough on the hierarchy, boy, you've got everything, right? And sure enough, that person made unauthorized copies and put it on a USB device and went home and, did some damage. And, this story, has happened so many times. We hear a lot about like North Korea or others, hacking these exchanges and so forth. But really, I think the insider threat is something that, a lot of folks kind of maybe don't pay a lot of attention to, and that's really where my interest in all this came in. IBM, of course, is a big company and we deal with regulated institutions. And when you're talking about keys, okay, in a traditional regulated institution, keys are just something, you use to process stuff with. It's, no big deal, right? But of course, in digital assets and especially crypto, blockchain native, the keys are the money. All of a sudden you're using traditional technology to store money versus how it would be done in a regular fiat-based world, right? So Amazon is the world's largest bank, or I should say vault, if you will. There is more funds on Amazon, I dare say, than anywhere else in the world, okay, all in. And yet most of that is quite frankly vulnerable, right? Because, it's sitting on, and I'm not taking a dig at Amazon here, but I'm just saying on any public cloud, it's sitting on, infrastructure that, someone else owns, someone else maintains, right? You have no idea how that is being maintained. You just kind of have to hope. and that's where my interests lie. Because IBM, we had technology that introduces this notion of technical assurance. And I'll talk a little bit more about this, I think, later on, but generally it's technology prevents you from being evil. So we just assume everybody's evil. And how can IBM technology make a difference in this digital asset space? By protecting databases, by protecting wallets, by protecting processing information, obviously private keys and things of that nature, in a way where others who are not supposed to have access just can't get it, And how do we avoid creating honeypots of key material, honeypots of funds, in essentially, right? And how do we do that? And we do all of these things. And so in 2018, I realized, we're sitting on all this technology. We're not really using it for this. And I made a pitch to the general manager of the IBM Systems mainframe organization, Ross Morey. And I was given a slot by the head of research who was taking a bet on me, and Donna Dillenberger. And she basically said, look, you can take my slot at this briefing, okay, and go in there and basically pitch that you can get fintech startups to buy mainframes. and to do that to protect Bitcoin, on a crypto exchange. And well, I was fortunate because I was able to do that, and basically given license and resources to go build essentially a business inside of IBM Systems, for the sole purpose of applying technology that we had, and then helping to shape, how that technology evolves and new technologies, right? So that they can all kind of come together to really bring to bear our capabilities, into digital asset open finance, which is kind of what I think we are headed, right? I mean, someone mentioned to me yesterday in a meeting that we were having, when we think about where, financial services is going, it just basically means this: more keys, more private keys, right? It's not going the other direction, okay? So, if you can't look after the basic fundamental thing of a private key, then you're really going to have a hard time making it, in this sort of next generation that's coming. So IBM, I think we're very fortunate, that this big company at least took notice and said, okay, we can invest, one or two people and see what happens, right? And if they're onto something, then we'll support them. If they're not, they can go look for a new job. So, that's basically how I got started in 2018. And 2018, 2019, 2020, here we are halfway through 2021, and a lot of things have really, evolved. And I'm happy to say that, we have had quite a bit of success here. And I think the most important success is that, when it comes to these large banking institutions that are already sort of IBM clients, right? At least because of our brand, I can get the meeting and I can at least have a conversation with them. And, we talk about key management, and it's like, yep, they get it. I get it. We can have that talk and see where things go. And on top of that, we made a conscious decision, at least I did, that we would never compete with our clients. Okay, so whilst, yes, we can build a custody solution from scratch, we certainly have the expertise to do that, we choose not to. And we want to work with companies like METACO, right, who basically bring the thought leadership, bring the, if you will, the street cred to this market, and then support you in being able to, be successful, because your success, is our success, and that follows, and we all grow together. And I think it's good, quite frankly, because we need these kinds of successes to really help the community, which is fairly conservative. What I mean by that, the regulated community, to understand that, yeah, you can safely handle digital assets. You can safely operate against digital assets. And it's a long way to go. I mean, the biggest thing that I tell people, when it comes to proposals, is this. This represents a fundamental sea change of operations. It is a transformational change. When you adopt digital assets, you are moving from what you've been comfortable with for the last 50 years, okay, into something completely different, right? And it's not like, getting some kind of point solution and, bringing that in-house and doing a proof of concept and showing, impressing all your friends, that you can do this, right? That's not the point. In every one of these large institutions, you have a handful of people that, quote, get it, right? They have to have their own internal advocacy. They have to be able to, if you will, not sell the message, but also train and enable these these people to make sure that they're able to actually deliver on how to safely operate with digital assets. And this is beyond custody and keys, of course. This is business processes. This is risk and compliance. This is tying into the existing back-end systems like core banking systems, everything else. And that's extremely hard to do, right? So you're going to need to have a company, and companies that can kind of come in and help you do it all and be successful, not just in, being able to prove to somebody that you can custody a private key, but rather how you can revolutionize this entire industry and provide, access to financial services, in ways that heretofore are not even possible in the traditional financial services world, right? So we have this sort of vision of, we're on this journey, right? We're going to change the world, like one big financial institution after another, and this is why we're having this talk today, right? This is why I'm all geared up and passionate about this space, because I think we're on a mission, and we're going to get there.
Great to hear about the mission and the background. Thanks for that, Peter. So why don't we get a little bit into the meat of it, basically? So we often hear about things like confidential computing, and I would say the market. My observation generally is market doesn't always think too deeply about security. It's kind of like a good enough approach. So when you go to a client, how do you differentiate what you can offer in this space versus what is relatively crowded market in terms of, let's say, key management and solutions in the market?
Yeah, I mean, there's a lot of different ways to look after keys. There's, if you will, you have hardware secure enclaves to store, if you will, a whole key in. You have, let's go ahead and slice the key up using something called a SHAMR secret sharing, and then take these pieces and store them in different places. Okay, and then bring them back together, and then use it to sign a transaction. And then you even have something called multi-party computation, which basically is again involving key shards. In this case, everybody has their own that gets generated locally, if you will, and they don't have to come together in order to sign a transaction. It's kind of like voodoo magic. And any and all of these different ways are ways for people to securely sign a transaction, because as we all know in a blockchain, if someone else has access to your key material and they sign on your behalf, well, you're not getting it back, right? So this presents, I think, a very challenging problem for confidential computing in general, okay? So confidential computing is relatively new. It's all moving towards something called zero trust architecture or zero trust infrastructure. And in today, the public clouds all have their own variations and approaches to confidential computing, right? And so, you have things like trusted execution environments, like Intel Software Guard extensions. You have, Google has confidential VMs. You have Nitro enclaves over at AWS. And at IBM, you have something called HyperProtect, right? And HyperProtect is built on Linux-only versions of mainframes called Linux ones. And that's all they do is just Linux, right? So these are just different ways to kind of get to the same place. Now, most confidential computing does a few things. It protects data at rest, okay? It protects data in flight. And then it really, protects data in use, right? So if I have something, I'm doing compute on it, and I want to make sure that, no one else is doing compute on it, then I need to obviously figure out a way to protect it while computing, right? So that's data in use. And so all of the leading confidential computing, vendors out there support all three of these and do it differently, different price points, et cetera. We go one step beyond that. We have, I would like to call it data across, okay? So we have the ability to protect data as well as business processes across platforms, if you will, okay? And I think maybe what I could do is just give you an illustration of that, if you don't mind.
Please do, yeah.
Okay, so let me just do that. I'm gonna share a slide. Let's go through an example of what I mean when I say sharing across. Okay, so let me know if you can see the slide. All good? Okay, so this is gonna be like a business process flow. We're gonna go ahead and design it around how do you approve let's say, a digital asset custody transaction. Okay, so we have somebody that's responsible, for defining what we call a policy, right? And then we with that policy, we can, pull in existing rule sets and workflows to build upon it. We can sort of say, okay, who's authorized to do what as it relates to this workflow. We can bring in various pricing oracles and other sources of data. We can integrate it into anti-money laundering solutions as well. We can go ahead and have it define with each group in, let's say, a large institution, compliance, risk, operations. They all maybe have their own bespoke kind of rules that they want to implement. Maybe they'll operate in quorums when it comes to actually doing authorizations. And then finally, you need to tie all this stuff, as I mentioned earlier, into like back-end systems, right? So you have to integrate all of these things. And then this business process flow itself has to be, audited and non-repudiable, right? And so, a lot of today you have solutions out there, rules engines and things like that, that will allow you to do that, right? A lot of times they're, somewhat working with just one solution. Other times they're going across solutions. So for data across for us is the ability to ensure that a business workflow like this is also subject to confidential computing. And I'll show you now why that's important. Because let's just say that business workflow is running in some kind of commodity system out there on some public cloud, doesn't really matter which, okay? And there's a system administrator for that cloud that has the responsibility to maintain the infrastructure that policy is running on, okay? That policy engine. Now, it just so happens that what happens if you have an evil administrator also working at, let's say, the same public cloud, or perhaps someone that works at the company that is responsible for the rules engine itself. Either way, sends an email to their good friend, the system administrator. Of course, they're going to open that email because they're good friends, right? Why wouldn't you? And of course, in doing so, let's say that, it actually had some malware in there, and now we have what's called a system takeover event, right? So the evil administrator now has the credentials in order to run commands on behalf of the system administrator. Now, in this case, the system administrator has no idea. But when the evil administrator runs this command, which is a Docker permission escalation exploit, the evil administrator now has the same capabilities as the system administrator, in a sense, like they have access to the keys, right? So they can kind of then do stuff. Well, what they can do is go ahead and get access to that business process, right? And with that access, okay, going back to this process, what happens now if the person who's responsible for defining and operating that business process flow is evil? Like what things can they do? Well, they can go ahead and they can change who's involved, who's authorized. They can get in basically in terms of the approvers, they can reduce them from the quorums to maybe just that person themselves, right? So all of these things are basically really bad, right? Because you have the ability to change the policy, because you have access, right? Because you're evil and malware and all that kind of stuff. So what can we do as a way to prevent that from occurring? So one thing we can do is we can take this workflow, this policy, and we can set it in stone. We can set it in stone, people, so that way it cannot be changed, right? And then that will go ahead and provide the ability to separate controls. The people that maintain the policy are not the ones who then execute the policy. And if you want to make a change, you have to basically redo it, because that policy is now code. The policy is a binary image, right? So we've solved the problem, right? Maybe not. Because what if the evil person is the person actually deploying the policy as code? Then what? Now you've got another problem. You see, you've put a backdoor into this image, and now no one has any idea because it's just a bunch of zeros and ones, right? So you could basically build it with a backdoor, or later on, depending on where you deploy it, you could swap it out, right? So you got two problems you have to deal with. And I think this is where confidential computing comes in. How do you solve for this? Well, let's take the second problem first and the first problem second, because we're IBM and that's how we operate. So if I want to prevent somebody from swapping out that image, that compliance as code, okay, what can I do? Well, I can put it into a confidential computing enclave. Okay, at IBM, this is called a hyperprotect virtual server. Now, again, this is kind of where the differentiation appears, but you can do this on any of the major clouds. Where we are slightly different, okay, is that in our enclaves, they're designed with technical assurance, meaning that administrators do not even have a command line, do not have a secure shell. They have no ability to actually get in there and do stuff. So they can't swap it out, okay? There's no access to memory, no access to the operating system, the processor state, okay? Even all the dumps, if you will, if you try to dump the memory, it's all encrypted. You don't have access to it. And from a development perspective, you don't have to do anything special. It's just Linux. You just deploy, into that environment, and essentially IBM takes care of the rest. Okay, so this is how we solve the problem of if you put it someplace where nobody can actually change it. How do you solve the problem to ensure that originally there was no backdoor put into that image? So let's take a look at that. So the first problem we solved with something we call secure build server, and this is unique, by the way, to IBM. No one else can do this, and the reason for that is that we can build any kind of sized application stack in one of these enclaves because they're 16 terabytes in size. Okay, now use a signing key. Let's say the bank, because this is about the bank controlling their own data, for example. So the bank has a signing key; they own it. They can verifiably sign any image. Well, so anybody can do that. That's nothing special, right? But if the bank wanted to prove to a regulator exactly what was in that image, because what we're talking about is deploying code that basically operates against funds, okay? So it does matter. And if you want to prove to a regulator that in fact there is no backdoor, that you are deploying what you think you are deploying, we have this thing called a manifest, and that's that little green thing in the middle of the enclave. And the manifest is all the executables that are part of that application that's being built. And that manifest, that is where technical assurance comes in. It is now available to an auditor, okay, your regulator, whomever. They will go ahead, review it, sign off, and then it gets pushed to the place where it can't be changed. Okay, and so this is how confidential computing ensures that applications, databases, wallets, and even business processes are hardened. Okay. And therefore, the ability for insiders to act is significantly reduced. And this is where IBM, I believe, contributes to this industry the most.
Thanks, Peter. Maybe just to emphasize it, I mean, I think a lot of firms will promise, operational assurance, and you're talking about technical assurance. What are the key differences of that? Just to highlight given this is such a USP, right? That's a great question. Let's do that in the context of key management as well. When you say operational assurance, you mean you have policies and procedures in place to make sure that bad people don't do bad things. And I should say bad people because what? Our perspective is that all administrators can be corrupted because you're talking vast sums of money and people who have access to it who are not usually well paid. Okay. So guess what? There's a built-in incentive here, folks. So just, understand what you're facing. Okay. So you really want an ability to get away from operational assurance. You don't want to rely on goodwill. You want technology to get in the way, right? And so, we saw that if you deploy your applications in hyperprotect virtual servers, if you use this secure build server, you have technical assurance to ensure that your applications, your databases, your wallets, and your policies are not going to get messed with. Okay. And even when you deploy them, that kind of leaves us with one other area that we should probably talk about. And that is the private key, right? How can a bank control the private key in a way that's technically assured? So let's think about how you might be able to do that. Okay. So I'll just share one more slide if you don't mind. This is kind of how we do key management a little bit differently than most. In IBM, little history lesson, we invented something called the hardware security module. Okay, that's an HSM. And that was done because we invented the automated teller machine where you go and you type in a PIN code
okay, from a card with a magnetic strip that we invented, okay, that allows you to get money out of, yes, true, out of the automated teller machine, right? So we created the entire thing. And what we realized back in the 1970s when we did this is that, hey, you're going to have like billions of these PIN codes. Are you going to put them in this little thing called a hardware security module? Answer, no. No, you're not. What you're going to do is you're going to make this thing, you're going to design this thing in a way that you don't have to do that, okay? And so what we did was we designed it in a way that you store one key. And that's something called a master key. And on this slide here, you see it's a blue key, okay? Now, before I talk about how we use that, let me talk to you about how we get it there. That blue key is what's called technically assured, right? So if anybody tries to get access to that, I will soon show you what can happen. Generally speaking, it's not good, but it's a little bit of James Bond technology, okay? Now, the master key, therefore, is non-extractable. IBM administrators in the cloud, your system administrators on premise do not have access to it, guaranteed. This is another thing that we can say, right? Because it's been rated as the highest commercially available hardware security module on the market today, FIPS 140-2 level 4, and soon FIPS 1- level 3. Sorry, FIPS 140-3 level 4. Yeah, thank you. that's coming. Now, in order to get that key into the blue key into the domain of the hardware security module, we have these things. In my hand are also hardware security modules, and these are smart card hardware security modules. And what you do, you take one of these and you generate a number, a random number, okay, with a true random number generator, and then you basically transfer that number and it gets assembled into that blue master key. Like we put it together as the summation of the numbers that we got from these smart cards that we have in a ceremony. And this is where the technical assurance comes in. As you know from METACO and your banks, they're the ones that actually own these smart cards. So METACO has the ability now to say, we have no access to your keys, right? Because they're the ones that own these smart cards. Now, when they create the master key, the next thing we do with it is something called external envelope encryption. And that's a at the triple E. And all it really means is this. I have my master key, which never leaves, and I generate some Bitcoin seed or other, and then we literally wrap it, we envelope wrap it, if you will, okay? And we transfer that into what's called a secure key, an AES 256-bit secure key. And then from there, we store it in something called a cryptogram, which does additional things like encrypt metadata. And that's where it stays. So the key material is actually designed to be stored outside of the HSM, which is different. And therefore massively scale. One master key can generate and encrypt, okay, an infinite number of private keys, okay, one. So that's pretty cool. So let's take a look exactly how it works. Inside the secure element of the HSM, we wrap it, we then transfer it into a cryptogram, and we push that in something we call nearline storage. Nearline storage is another concept from the 70s. It basically means this. The data is an inaccessible state and stays there until you need it, and you can get it without having humans. And I say that because, when we think about cold storage, involves humans. That's the whole point, right? We've got something offline, we need to bring it online. Usually there's a human involved. And you know what? Where there's humans, there's internal attack vectors. And so if you can get the signing done through policy, like we talked about, that hardened policy, and you don't need humans, okay, you can basically reduce the number of opportunities to kind of have an attack, if you will, okay, from an insider. And that's what we do with this nearline storage concept. And another thing that's kind of cool about it is that, if the bank, let's say he's using a custody platform, right, like METACO, okay, if the bank ever wants to prevent access by the custody platform, all they have to do is zero out that master key, and now access is frozen, if you will, okay? And and increasingly, and Seamus, I think you know this, we see especially with a harmonized product, the ability to orchestrate across multiple custody platforms, and the ability then to use this master key concept to provide ultimate control to the bank, right, becomes very helpful. Because if every one of the custody platforms has been generating their key material and signing using the master key, all you have to do when it comes time to switch from one to another, okay, is to simply rewrap the wallets with the new master key and then zero out the old one. And now you have basically transferred assets from one provider to the other without having to go on chain, without having to introduce counterparty risk, and without having to pay anything, which is quite useful. And so this is how IBM's technology can be used to sort of facilitate essentially a trend, which ultimately is a multi-platform capability. Because the banks, the big banks, they want to reduce the risk, right? They've got all of the risk, and yet they don't own the assets. Yeah, so if they're going to go ahead and do that with multiple providers in case something goes wrong, then it's a good way to kind of help give them control and retain control over all of them. And they can do that with these smart cards. And I'll just close by saying one little thing that actually kind of seals the deal for us. You know, when it comes time to protecting the key material, what we do is we protect the master key, okay? And we are certified by NIST for any one of these attack vectors. This is legit, okay? If I have an electromagnetic attack, a voltage attack, a drilling attack, an X-ray proton beam attack, okay? In 100 nanoseconds, that key is zeroed out, effectively putting everything that was encrypted by that master key as frozen. You don't lose it, it's just frozen, okay? 100%, nobody is going to get your keys, okay? And if you need to basically redo it, you just simply get another domain, get your smart cards out, and you have a ceremony and reestablish that, and you're back in business. And there you have it. So this is how IBM provides technical assurance to keys, technical assurance to business processes, technical assurance to applications, technical assurance to databases, right? And does so in a way that prevents insiders from being successful in their attacks. And we believe institutions that are regulated require this level of protection.
I think it's a strong message, right? I mean, giving clients control and eliminating the need to trust. I mean, it's very, very powerful in this context. You know, there are a lot of other questions I had. We're running a little bit short in time. I wanted to talk about the kind of keep your own keys, the bring your own seed concept, but I think we'll have to save that for another time, just given that we're running a bit short. But I would like to wrap it up. Just, you know, you obviously talked to a lot of institutions, and just at closing, you know, where do you see, where do the banks or larger institutions that are building this space, what do they get wrong, or what do they underestimate once they start on the journey to build a digital asset stack?
Yeah, that's a great question. I think what they think they can do is basically contract with a fintech company, and the job is done. Most fintech companies, unfortunately, really don't have a good understanding of what it's like to deal with a regulator. Okay, and so while you have their best shot at, you know, from a policy perspective, how you can, you know, operate, do compliance, KYC, et cetera, when you are facing the regulator, they ask a lot of hard questions. And all of the custodians that became in the US national banks through the OCC, and we know this firsthand because we work with them, right? They all learn this, that, you know, it's a lot harder than you think, right? And, you know, certainly the fintechs have a lot to learn when they start to become banks and regulated institutions themselves. But the regulated institutions, on the other hand, coming from the other direction, certainly understand what it's like to deal with regulators, right? But they just have no way of translating, you know, those obligations into this new tech, because they don't even understand it, right? And even those that do understand it, you know, it's like you're dealing with sort of like out of the box appliances. How do you change the tech, right? So that it actually conforms with what the regulators are requiring so that we can do business. And I think, you know, the good story there is a lot of this is starting to happen. And, you know, just recently, we saw in DeFi, the lending platform, Aave, talk about something called Aave Pro, where, even these DeFi platforms, the decentralized, no way regulators getting, touching me, they realize this, you can't stick your head in the sand, forever. You have to come out and you have to deal with regulation. You have to deal with regulators. Okay, you've got to create products that can do KYC and AML. And so Aave, for example, is teeing up, Aave Pro, which essentially is a pre-KYC'd, a way to sort of interact with that platform, essentially creating kind of a walled garden approach or whatever. But institutional DeFi itself is coming. A lot of the big banks don't have yet, depending on the jurisdiction, authority to deal with cryptocurrencies, right? But cryptocurrencies are only part of the spectrum. In the middle of the spectrum, you have tokenized assets that are, stocks, bonds, corporate bonds. There's plenty of use cases, at least in the corporate bond type of thing, right? And then, of course, there's digital securities on the far other end of the spectrum, which definitely blockchain native assets is maybe sometime in the future. I mean, right now, the closest I'd say to a digital security is a fractional NFT, which I think very few people understand actually is that. So we'll see where the regulators come, right? But ultimately, if you're an institution that is regulated, you got to figure out how to deal with all this stuff, okay? And you're going to need technology, and you're going to need thoughtfulness, and you're going to need advisory, and you're going to need companies like IBM, quite frankly, that kind of bring all this stuff together, right? And enable you as a regulated institution to sort of get onto this journey, right? As I mentioned before, this transformational change journey going from today's operations, right, to bring in these fintechs, but in a way that is, compliant, okay? And it just kind of works, right? And I think this is why IBM is still relevant to this space, because we understand the regulated world. Like that's what we do, and so we work with fintechs like yourselves, right, to be coming together, and to provide that whole new operating experience, for these large banks, as well, quite frankly, as some of the fintech custodians that are becoming banks. So it's really interesting times.
Well, I think we're out of time, Peter. Thanks. That's a great way to sum it up or wrap it up. I would say that, good thing that these are recorded, and if people want to go back, and there's a lot of granularity, a lot of detail, if they want to dig into it again, the recordings are on our website and all the major podcast platforms, they can do that. So thanks again for joining us, Peter. And
thank you very much.
Happy to have you back again to go into more detail. And the rest of you, everybody else, see you again in 2 weeks. Thanks for joining.
Thanks so much. Thank you.